Okay, now, the reason why I wanted to show you that mistake is when I first read this last night, that's what I did in my own mind.
You made a mistake?
Yeah, well, I definitely made that mistake. I was thinking about it, and I said, well, this is the length here, and that's the height, and then I get that finite number. So I must have done something. I must have goofed something up. Okay, so let's be a little bit more careful. Okay, this goes on the inside, right?
Yeah.
So you can see there's a little tiny distance there. You see it?
Yeah. So
Which is this distance here. And so I have another triangle that looks like this. Okay, it comes out here, then there's a right angle, out like this, then a right angle, then this height that we just found, which was our height of the rectangle divided by 2n cubed.
Yep.
And then this distance in here we have to find, and then here's the actual height of our triangle. Okay? All right, it's kind of hard to see. Do you see it in the back there?
Yeah.
Our triangle comes on the inside, here's the base, and then in the back there is the height.
Yep.
Okay, this is what we actually want to find. Okay, we thought, hey, it's about equal to this, so let's just approximate with that.
Yeah.
But then something broke. So let's try to figure out why. Okay? So let's find what this distance is here. Okay? Now this is not the easiest distance in the world to find. But we do know that if you go all the way from the center here up to there, I get a radius. You see that?
Yeah.
From the center of this circle out all the way to the edge, I get the radius.
Yep.
So I'm trying to find this thing y,
But
which is just this little extra bit that's left over. But the nice thing is I already know what this x is and I know what this r is, so that means I can find this thing using the Pythagorean theorem.
awesome.
Okay, so here's my x, here's my r, and this is what we're trying to find. This is one thing we're trying to find, so let's find it. So this bit, let me call it a.
Yep. Right.
A squared plus x squared equals r squared, right?
Yeah.
Okay. We already said that this x was about r times pi over n, right?
Yeah.
Because 2 of it was all the way across.
Yeah.
So a squared plus r squared times pi squared over n squared equals r squared. A squared equals r squared, this r squared,
Yep.
minus r squared times pi squared over n squared.
Whoa.
Okay? I'm going to factor out an r squared.
Yeah.
1 minus pi squared over n squared. Do you see that?
Yeah.
Okay. Now I'm going to take the square root of both sides. I'm sorry this is a little more complicated than what you've studied. A is r times the square root of 1 minus pi squared over n squared.
Yeah. And then the squares cancel.
No, they don't. The square roots don't quite work like that, right?
Yeah.
Right? But that's okay. That's okay. That's a very common mistake.
Yeah.
But that's all right. Don't worry about it. That's we haven't even talked about square roots.
No.
Okay? But this, as n gets big, this number pi squared, which is about 10,
Yep.
divided by like 1,000,000, gets very small. So this square root becomes very, very close to 1.
Wow.
In fact, a formula from calculus tells us that this is approximately r times 1 minus pi squared over 2n squared.
Whoa.
Okay?
So it's really close to 1.
It's really close to 1. Okay? But if this is r times 1 minus pi squared over 2n squared, that means this little bit up here, which has to be added to this to get to r, is just pi squared over 2n squared.
Whoa.
Okay?
Awesome.
Okay. Now, so now I have my triangle. This is pi squared over 2n squared. Now, I went through that kind of fast, but this bit here is r minus this little bit. I know the whole thing is r.
Yep.
That means this extra little bit subtracted off must be just this tiny bit here.
Awesome.
Okay? Now, does that make sense?
Yep. Yeah.
Are you sure? Okay, so now I have an interesting triangle. Pi squared over 2n squared is this distance, and the height is h divided by 2n cubed. Okay?
Yep.
So here's the very interesting observation and what we got wrong in the mistake I made last night thinking about this. When n gets really big, which number is bigger? 2n squared that I'm dividing by here, or 2n cubed? Which number is bigger when n gets really large?
I think it would be 2n cubed because 3 is bigger than 2.
Okay, so like if I had 10, for example, what's 10 squared?
It's 100.
What's 10 cubed?
1,000.
1,000. So even when n equals 10, here I'm dividing by 2 times 100. Here I'm dividing by 2 times 1,000. What about when n's 100? What's 100 squared?
It's 10,000.
10,000. So when n is 100, I'm dividing by 10,000 here. When n is 100, what's 100 cubed?
It's 1 million.
Okay, here I'm dividing by 2 million.
Whoa.
So I've drawn my triangle wrong.
So
This isn't the long side, and this isn't the short side.
it's the other way
It's
around.
the other way around. So this triangle here, the picture misleads you. This is the longer side, and it's longer by a lot
Yeah.
because you're dividing by a much smaller number. So this triangle, instead of looking like this, looks like this. Okay, so this is the height of the this is approximately the height, right?
Yeah.
Okay, this is very tiny, so my height of my triangle is approximately pi squared over 2n squared. Okay?
But the sides look longer.
Okay.
That side looks this
Right,
side.
and that's because I remember I told you we made a mistake?
Yeah.
We made a mistake. So here's my height, pi squared over 2n squared. Okay?
And
All right?
yeah.
Okay? Now, oh shoot, I erased what x was. Do you remember what x was? Here?
It was.
It was 2 pi times the radius, it was pi times the radius over n.
Yeah.
And so my base of my triangle here was twice that. Okay, so the area of my triangle, here's my base.
Yep.
Okay, 2 pi r over n times, here's my height, pi squared over 2n cubed, and then times a half, 1/2 base times height.
Yeah.
Okay, so I get 2 pi cubed times r.
Yep.
Yeah.
2 pi cubed times r
The hat two. Oh, I know.
over 4 n. Oh, sorry, this isn't cubed, it's squared.
N cube.
Over 2n, 4n cubed. Okay, now I have to multiply by 4n to the 4th.
Yeah. It does that.
Okay, but I have now an n to the 4th over n cubed.
You get.
Okay, 4's cancel. And I get n to the 4th divided by n cubed is
Just N.
n. So I get 2 pi cubed times the radius times n.
And that's our area.
That's our area. Now what happens to this formula when n gets really large?
It gets larger too.
It gets larger too, and it goes all the way to infinity.
Infinity.
So when you see the pictures of this Schwartz lantern, and all those triangles all get smushed together, the area will get larger and larger and larger. And so you get an approximation to
This.
a can, a cylinder, that has the right circumference.
Yep.
It has the right volume. Like if you poured water into it, you would fill up the same volume.
Yeah.
But the area is infinite.
Whoa.
That's pretty neat, right?
Yeah.
Okay. And so if you were advanced students in calculus, this would be a great lesson about how you have to be very careful about how you approximate things. But for you guys, it's just kind of a fun thing, right?
Yeah.
Infinite area.
Whoa.
Make sense?
Yeah.
Okay. Good job, guys. I know that was some tough math, but that's a very fun project.
Yeah.